All right, so we're going to go over just a little bit of like Pascal's triangle and the binomial theorem. This is kind of like your crash course or just a refresher if you're watching this later in the year. So Pascal's triangle is this triangle, which is a tool that we use to help us apply the binomial theorem. So your binomial theorem we can use anytime we have a binomial, two terms, to any kind of like exponent. So squared, cubed, to the 5th, to the 17th, doesn't matter. This theorem and the triangle will help us multiply that more efficiently than if we had to do it all by hands, like doing a box or multiple boxes, which gets very long and tedious. So we got a couple examples here. So we know how to multiply out x plus 3 squared. That's just x plus 3 times x plus 3. We know that gives us x squared plus 6x plus 9. That one's pretty straightforward. If we have x plus 3 cubed, again, a little bit more challenging, but still something that we can accomplish. So multiplying that out, this is the final answer that we get. Now, if we go to anything past that, again, it becomes very tedious and very time-consuming, lots of room for error. So we have this theorem, the binomial theorem, which kind of shortcuts that for us a little bit. I know it still looks like this is crazy long and complicated, but believe it or not, it does help. So the things to know, the big things to know in this explanation and all the rules that you have, A is your first term. So I'm going to be using the example x plus 3 squared. A would be x. And b is your second term. So in our example, b is going to be 3. So when you are applying the binomial theorem, your first term is always going to be a with the degree n. And n is that exponent that we have outside our binomial. So again, like for this example, it's 2. So your first term would be a squared times your b term with a degree of 0. And that's how we're always going to start it. Your first term times the degree n, whatever the degree is of your problem, times your b term with a degree of 0. That will always be the same. That will always be the same first start. So for our example, again, the x plus 3 all squared, your first term is going to be your a term, x squared, which was our degree to begin with, times your b term, which was 3, with a degree of 0. From there, each term after that, the degree of A is going to decrease by 1. The degree of B will increase by 1. So for our second term, I'm going to skip down a little bit. Our second term, instead of x squared, we'll have x to the first. We went down 1 degree from here. And then times 3 to the first power instead of 3 to the 0 power. Now, what's new on this is the times 2 that we often also have to catch from your Pascal's triangle. So the first term that we did was times the 1 out here, which doesn't change anything, so we didn't have to write it. Now, our second term, we'll do the deal with the a and the b and decreasing and increasing your degrees there, times 2. So times whatever number happens to fall in the triangle for the term that you're on. And then for our third term, again, we'll decrease the degree of a 1 more. So now we're at x to the 0 times 3 to the second. So we increased that degree 1 more. And then times the final one that we have here. So not going to change a lot by that times 1 there, but I did want to include it so you knew where it was coming from. So on the most basic level, that is how we will apply the binomial theorem and the Pascal's triangle. So we've got a bit of a Pascal's triangle here, and you may have noticed some patterns that are happening with it so far. You might have enough here. You may be in a situation where you have to create your own to solve a problem, like you don't have a Pascal's triangle on your notes. Maybe you're doing homework or a test. And so we will carry down the ones essentially, and then you add like the ones above it to get the next one. So like 1 plus 1 is 2, that's where the 2 came from. And then we just bring down the 1 on the outsides always. So bring down the 1, 1 plus 2, 3. 2 plus 1, 3. Bring down the 1. So we have this notation here, which is a little bit different, and it's up in the top, so you'll see that in some of this explanation. But if you ever see it written out like this, which we might see on the back side in a moment, this is just saying the rth element of the nth row. So that's basically just like which element are we in, and then n is like which row are we in. So starting 0, row 1, row 2, row 3, etc. So that's what that notation is saying. So again, we have another like Pascal's triangle here, and I've marked it up a lot for some problems that are following, but it says that this fifth row is circled. So in the fifth row, that would be like, what was it, the rth row that we talked about before? Yeah, the rth row. So your fifth row is here. The first 10 right here would be like the third element, or sorry, the second element, so that's that notation that we were just talking about, and then it's the 10, so that's kind of like the coefficient that we're going to use when we start multiplying all the things out later. This is stuff that you don't have to know, so don't worry about memorizing that. So we're going to kind of use that triangle in the binomial theorem to expand this x plus 2 to the fifth, and I've kind of already, I've already done it, so it's already worked out, but I'll walk you through. So one thing to note, which kind of helped me, is that for every term we have, your exponents are going to add to whatever our degree is. So just something to think about as far as like if you're finding a specific term or just going through and making sure you're doing the right things. So like I mentioned before, we're going to start with your a term to the whatever your degree is, so x to the fifth times b to the 0. So I just didn't write it at all because anything to the 0 power is 1, doesn't change that. And again, we're multiplying by the one that's in this row as well, so we don't have to worry about that. So since it's to the fifth, we're using our fifth row, row 3, 4, 5, for all of our coefficients from the triangle. So I'm going to try to have this where we can see everything. For the next term, it's going to be 5 times whatever, and I'm just pulling that 5 from our triangle up here. And then we went down 1 degree with x, so to the fourth times your b term. And if you notice, I circled our exponents, again, are going to add to your total degree, which is that 5 out here. The next term plus your next term will be 10, pulling from your triangle, times x to the third times 2 to the second. So decrease with the a term, the x term, increase your degree with the b term, or our 2. And then we continue with the next term, again pulling the 10 from the triangle. Your exponent is 2 on the x now. We went down 1 more, go up 1 on the 2, so times 2 to the third. Your last term would be plus 5, so again you're getting 5 from your triangle. X to the first, we went down just 1 more degree, times 2 to the fourth. We went up 1 more degree with that, and then your final term, we have like the times 1 here, which isn't going to affect anything. X to the 0 power, again, it's not going to affect anything. That's just times another 1, and we're left with 2 to the fifth. So that was the only part that I wrote out. So once you have that like framework, essentially, you can do all the multiplying and the simplifying, reducing, and then this is our final answer. So we just have to go through that process once, kind of, rather than doing like 7 or 8 boxes. So you can see how that kind of helps a little bit. So hopefully that makes some sense. And again, this is just kind of like a brief refresher or catching you up a little bit on the Pascal's triangle. Yeah, that's about it.